Good morning, good afternoon, good evening, everyone. Thanks for joining. This is Arun here. I'm your host for the webinar today. And then really appreciate you taking your time to join us today for the webinar. The topic of the webinar is Git-based security workflows for developers. Right? Looking at solutions or ways of approaching application security, which is purpose-built for developers, with developers in mind. Now, when we were thinking of does this webinar make sense to do, we did a survey among our customers and also people that we have encountered in the field, people from the industry, and what we got as a response, and this was an overwhelming response, and this is not just 2 people or 3 people, this is hundreds of people responding to the survey. And the audience was mainly developers, development managers, team leads, but all from a development persona. And an overwhelming percentage of them, 96% of those people, reported there's a huge disconnect between AppSec and engineering workflows today. And that disconnect hurts their productivity. Right? And so we realized, okay, so this is indeed a topic of concern, right? Wherein the development community definitely feels like whatever AppSec is doing and from a workflow perspective is not well suited for how developers like to work. So we then tried looking at, okay, why is this? What has happened for this huge discontent among developers? So we started looking at the evolution of both AppSec and the developer workflows. So think of it like the software development lifecycle. So for the developer workflow, over time, this is how things have progressed, right? Wherein with the whole open source movement and the ability to use libraries and dependencies, and then with things like virtual machines, where it made development much easier, and then came along cloud. And with that, continuous integration was made easier. And then people realized, okay, in a distributed environment, something like Git makes much more sense. So Git came along, and then continuous deployment started happening, wherein people are deploying multiple times a day. Gone are the days when you had 3 months to make a release. Things happen much faster nowadays. And then when things happen much faster, they realized, okay, I can't develop a monolith app, let's break it into pieces. So then microservices came in, and then engineers realized, okay, hey, always it comes in saying it works for me, right? It works on my machine, then why isn't it working in production? So what if we can create something where if it works on my machine, it works in production as well? I have that confidence. So then came along containers, and then you had this whole orchestration layer to manage all of these. So software development lifecycle in the last 10, 20 years has come a long way. Right? And then as you can see from an innovation perspective, this is progressing along really exponentially. But at the same time, when we were to look at application security, it hasn't had that kind of an innovation. Right? Around when virtual machines came in, just before when cloud started becoming popular is when, say, OWASP was founded, SAST, static analysis tools came into existence. Then people realized, okay, I can't do everything in code. Maybe I need something in production. So then web application firewalls came in. People tried to solve issues with static analysis, with dynamic analysis. And then there was a significant amount of time when nothing much happened in that space, right? People just learned to deal with these tools. There are issues with it, but there's nothing better available. So people just learn to live with it. And then when the open source movement and libraries and dependencies came along and vulnerabilities in that became popular, or became an issue rather, software composition analysis, SCA tools started becoming popular. And people then tried to solve issues with static analysis and dynamic analysis by coming out with new category tools like IAST, interactive application security testing. right? And then people realize, okay, none of these are actually catching issues to the way we want to. And so of late, things like bug bounties, HackerOne, and penetration testing as service, all of these are also coming along. But as you can see, the innovation is kind of incremental, right? Wherein the solution is to fix what is existing, find some gaps in it, and try to come out with something incrementally better, not exponentially better. And the biggest gap that exists is it doesn't match the innovation that is happening in software development life cycles, right? Where when this was the gap early on, when it was narrow and you could catch up to it, this is where we are today, right? When you're imagine if like bug bounty is the latest and you're deploying an app 3 times a day, 4 times a day, well, a bug bounty program is not going to be able to keep up with that pace, right? It's always after the fact. It is never with development. It is not happening at the pace at which developers are writing code. So it is an issue, right? And that, I believe, is why on the previous slide, when we saw that developers are not happy with AppSec workflows, this is the root cause, at least what we believe. And of this, the reason I marked Git in a separate color is I think that was a major turning point, and hence why the webinar title also has Git in it. Now, why is Git a turning point? So as all the developers in the webinar today would realize, years back, I'm sure these tools, there are companies who use them today as well, but they're not suited for the modern age in terms of speed, right? So like things like Subversion and Perforce and CVS and the centralized development mechanism, wherein when you had to make a change to a file, the first step was to check out a file, right? It was a hard lock on the file where nobody else could update that file when you had it checked out. Now, when it's small teams working independently of each other, where if I were to touch a module, I know nobody else is working on it, and I had the luxury to lock a file and edit it, and then check it back in when I feel it is ready. That used to work. But now in this day and age where there are many people, many teams, geographically dispersed, touching the same module at the same time, this kind of centralized approach doesn't work. And it is slow, it hampers innovation. When you're like, I remember when I used to develop using these tools on the left, the first thing I need to check is, okay, hey, is somebody working on this module? Right? And then it was easier back then when I just had to like walk over to that person and talk to them. It doesn't happen these days. That's not how development works. And that is one major enabling factor with Git, right? When like on the right, I've just listed some of the vendors which make it easy, like GitLab, GitHub, Bitbucket. And let it be open source development, let it be development within enterprises, small and medium businesses. Git makes that velocity much higher for development. Right? And that is one big jump in that innovation for software development. Now, when this increase in velocity happens, that is what we believe caused AppSec to be more disconnected. Now, why is that? When Git enabled velocity of development on the left-hand side, the average release frequency jumped exponentially. Now, all the customers that we speak to here at Shift Left, when we are developing software, we release multiple times a day. And it's very quick, right? Like a customer issue comes in, or say we are working on a feature, or we're working on a bug fix or a hot fix, or whatever is that you're working on. Back in the day, it was something that you scheduled, right? You would say this is part of your next release. Now, when is that release? It's maybe a month out. Then you start planning backwards. You're like working towards I mean, back in the day, maybe even working towards hardware requirements, you would think of the security implications of it. And then there was a long lead cycle before that went out into production. It went out even into staging, for that matter. But that is not the case anymore. Like, it's multiple times a day. It's numerous times a week. Very few organizations are still doing releases less than a month. At the same time, on the right-hand side is the frequency at which you're scanning the changes you make in the application, right? Wherein if you see the number of applications that are scanned per year, a lot of applications are scanned once a year or a few times a year. And when we ask customers and organizations we speak to, like, why is that? And they said, well, in most situations, it's because we are forced to scan, right? Like regulations or compliance, or it's just a checkbox saying, yes, we have scanned it. And so that's why it is being scanned. And it is just happening as something on the side. It is not given back to the developers. Even if it is given back to the developers, it's much later in the cycle. And not all changes or applications are scanned frequently, right? So if you were to overlay this, when 70% of the people that we looked at as releasing multiple times a month, less than 82% of those same customers are scanning monthly. So it's a huge disconnect, right? When in almost all the cases, the changes you made are never scanned in that same time. It's pretty evident. Now, let's see why that is happening, right? So if we were to look at how a modern development cycle looks like, why is this disconnect happening? So yeah, so this is another thing where when 18% of organizations are releasing daily, less than 0.5% of those organizations are scanning the code every day. Now, why is that disconnect? So this is an image which most of you would be familiar with, right? Wherein, hey, in Git, I've got this master branch, long-lived branch, whatever name that you want to call it, but think of this as that master live branch of which releases are made. And as most developers are familiar, whenever you're making a feature change, whenever you're working on some bug fix, whenever you're working on some change in that code, you create a branch of it, right? And then you create a pull request, you make some multiple commits on it, you do your unit tests, you do your peer code reviews, and then it gets merged back into master. And then you kind of move on to the next project. And so this is very familiar. This is how that flow works. But then let's see how AppSec works on this. AppSec at some later point in time invokes static analysis. They pull something off that master branch at some point in time. They run static analysis on it. They triage it to the best of their knowledge because AppSec is not aware of the code. Most AppSec teams are disconnected with engineering. And the bigger reason for disconnect is not because AppSec doesn't want to be involved. It's more of the proportion and team sizes, right? Most of the organizations we speak to, the proportion of AppSec to developers is anywhere from 1:50 to even 1:200, right? There's like one AppSec person to every 200 developers, right? I mean, forget even knowing the code. I mean, even knowing all those developers by first name basis is not happening. And then these groups all keep changing too, right? I mean, developers are not always focused on the same module, same task. They keep moving around. It's much more dynamic. So AppSec cannot practically be involved in day-to-day activities of developers and know what is happening. So they work off the master branch. They've pulled out something. They've done the scan. And then they're looking at it more from a security perspective, saying, hey, okay, this application is external facing. This is touching the database, which is production database. It has sensitive information. So, okay, I'm going to flag these SQL injections as potential critical issues, and I want some developers to look at it. Right? So, because again, AppSec also realizes if I were to push over the wall 500 issues, it's just going to sit on the shelf. It's not going to be looked at. So I need to prioritize what is important. So they look at some criteria based on application characteristics versus knowing the code. So they've triaged it, they've created a list, and then they send out vulnerabilities to the development team. And notice here it is sent to the development team, not to a specific developer, because again, the AppSec team in most cases wouldn't know who is responsible for this piece of code. Right? So it goes to say the application team, the managers, whoever gets that list. But then this leads to a bunch of questions from them, right? Even if it is to the developer, it's like, hey, I wrote this code ages ago. Like, I don't even remember what I wrote yesterday, right? Like, I need to go figure out what this meant. The most common ones are the ones in the green. They're like, hey, these are a bunch of false positives, right? And now I need to sit and triage these, and it's taking me away from developing my feature or whatever I'm working on. Or the most common question is like, okay, who wrote this code, right? I mean, maybe this scan was done 3 months after it was written. Maybe the person who wrote this code is not even within the organization anymore, or he or she has moved on to some other project or some other team. And then in geographically dispersed organizations, yeah, you might be able to git blame and find the person, but then it's a whole other process of like actually getting to them and getting their attention to look at this. Or it's very common that it might be a vulnerability in some shared library within the organization. And imagine the implications of that, right? Wherein, okay, this is something we encountered with one of our customers recently. One of their core libraries had a SQL operation, which was using some unsafe operations. And that library is in turn used by 20, 30 applications, right? So there is a transitive vulnerability where all of those 20, 30 applications are vulnerable. And so if I tell those developers that your application is vulnerable, they're like, yeah, but I don't own this piece of code. It's in the dependency. Like, we need to go ask those developers to fix it. And those developers, again, a common feedback is, hey, this dependency, this library had this vulnerability ages back. Like, I've not touched this code in 2 years. It's just that the applications have now started using that method, and that is why the vulnerability has come into the application. Now, you want me to fix the dependency? Well, it's in use by 30 applications, right? Now, you want me to fix this? Are you sure all those 30 applications are happy with that? Are they going to QA? Are they going to run one more cycle to validate it, right? So there's a lot of dependency. And the disconnect you can see here is the farther away that you give feedback, the tougher it is to fix it, right? So then AppSec thought, okay, if that is the case, let me change the place where this check is inserted, right? So they went on to say, okay, let me start inserting it earlier in the place in terms of, okay, let me put it into the IDE. Let me start giving feedback to developers as they write code. Or let me start putting it into the production environment, right? Which is slightly better than pulling the code 3 months later. But as most developers in the audience would agree, this is what, when we tell this to developers, the first reaction or the most common analogy I've heard is comparing ID integration to Clippy from the Microsoft old Excel and Word era, right? Right. When you start writing something in Word, Clippy pops up and says, hey, it looks like you're writing a letter. Can I help you, right? And it starts bothering you more than helping you. And it's the same thing with things like spell check and grammar check. You want to be in a zone when you write code, and you don't want to be constantly given feedback saying, you declared a variable, it immediately gives you feedback saying the variable is not being used. I'm like, yeah, I know, I just declared it. Like, give me a chance to use it. And then like you change the variable name somewhere, it'll say, okay, it's not declared. Yeah, I know, I'm gonna go fix that, but give me a chance to do that. So this constant feedback only throws you off, and then you start ignoring it, which then defeats the purpose of what security team had as an intent in the first place. So that's one. And second is there is no way to actually enforce or check whether developers are focusing on this, right? Because it's like spell check, where or like a grammar check. To make it happy, you can do things. It might not be the right thing because it's a tool. It's trying to second guess what you're doing. You can make it happy. As an analogy, the grammar check might not understand what you're doing, and it might say add a comma. You add a comma to make it happy, but actually that sentence now reads bad, right? It's not proper. But the tool is happy, and then what goes as a report is, okay, all the checks have passed. So in that sense, it's easier to beat those systems, but at the same time, it's also not good for developer productivity, right? When we ask security, where security is inserted, that's what we got from the left-hand side. When we ask developers, what affects your productivity, it's exactly the opposite, right? Where if half of the AppSec thought ID is a good place to insert, majority of developers thought that's the worst place to be inserting it. Right? So developer productivity is inhibited if you do this. So then obviously the question is, okay, what is the solution here? Well, the first common observation you might have had is, okay, we need to realign how these tools work. We need to realign how these roles interact with each other, right? And we need to identify efficient ways of doing this, wherein there are different requirements. It is not trying to just incrementally fix how an existing tool works. We have to fundamentally change how an existing tool works. That's the only way that a developer would be able to use these security tools without affecting productivity, without impeding what they like doing, which is developing features and writing code. So that got us thinking, saying, okay, then let's see something that developers like doing, right? Or a workflow that actually works for it. And then one such workflow is feature bugs, right? Wherein, again, let's put back that flow that developers are used to. I've created a feature branch. I've committed some piece of code, right? I created a pull request, and then I build the code and I'm doing some unit tests. And one of the unit tests came back saying, okay, there is some issue. I immediately fix it. I again send it back for peer reviews. The peer reviewer sees that you have done the test, you have found the issue, you've fixed it. He or she reviews the code as well. They realize, okay, hey, from a bug perspective, from a feature perspective, this is complete, at least with the test and with the reviews that we have done so far. And then you merge the code, right? And then this flow is what developers do day in, day out. This is just part of the workflow. And this works well because this is immediate, right? Like developers like it. Developers never leave their environment, right? Everything is just part of your workflow. You created a pull request, you do the unit test, you're getting immediate feedback. It is based on tests that you believe it is relevant because it is on the code that you just wrote. It is not telling you of the 30 other issues outside of the code you wrote because you don't need to focus on that. What you care about is what you just did and what you are trying to check in, what you're trying to merge. Right? So it is trustworthy feedback and it's immediate. That's the main key factor. And then from a organization perspective, so there is the unit test and the peer reviews which enforce the quality checks so that you're not allowed to check in bad code into the master branch. And then since the feedback is directly to the person who wrote it, there is the individual accountability, right? Wherein within Git, you can say, enforce these checks. You can't hide because these checks are also visible to your peer reviewers. So they're also seeing it. And so it is on the developer, and the developer has that mindset of getting these things to work. And also when there is the unit test or when there is these checks in place, the developer gets trained over time to know what the organization expects, right? From coding standards, from the security policies. So for instance, simple things like, okay, there are unit tests to see if you validate inputs, or like, so the unit test could be trying to put in certain types of inputs which the organization don't want to accept. And that is automatically enforced whenever you make a code change. So over time, the developer is automatically trained, and in future, they write code which meets that. Right? So it's not coming back as a later feedback. So I'm like, okay, so this workflow works. And we've asked the developers as part of our survey, and they're like, yeah, we like this. We are trained on this. We are used to this. And this is a workflow we deal with. So then obviously the question is, okay, can this kind of a workflow be applied to vulnerabilities as well, right? Not just bugs, not just code issues, but also vulnerabilities in code. Can that be applied? And that is kind of a demo that I'm going to show you right now, right? Wherein let's see how a workflow like that would look for a developer. So bear with me when I switch to the demo and then get a sip of water. At the same time, there's the questions window where you can always send me Q&A. I'll obviously be taking them at the end of the webinar, but please do feel free to send me questions in the Q&A window, and I'm happy to answer them. So jumping into the demo. This is a bit small. Try to this more visible. Okay, I think this is zoomed in enough. Okay, so let's start with Git, right? So I'm on GitHub, right? I'm on a JavaScript application, and I'm going to make some code change, and let's see how that workflow would look like. So I've got a JS file, and what I'm going to do is I'm going to come in and edit this file. Give me 1 second when I shrink my webinar windows. Okay, there you go. So edit the file, and then I'm going to come in and I'm going to say, okay, hey, there is this method for sending email, and I'm going to just uncomment this. I'm going to start using Mailgun, so I'm going to try it out. I'm going to hard code this key into my code, and I'm going to also log it into the console, and then I'm going to start using this, right? So I'm just hard coded this. Let me also maybe these. Okay, right. So I've made few changes. I've like hard coded a key into code. I've added some logging here. I've added some logging here. And as a developer would do, my next step is to create a branch and create a pull request, and I'll continue working on that pull request to make future changes, right? So I'm going to propose these changes. And I'm just going to make this one file change. So I'm going to directly create the pull request. I'm not adding any more files into the PR. And here, so this is, I'm in GitHub. It says, okay, hey, I've created a pull request in this repo. And then I've got a conversation window here, right? And one thing to note is immediately there is things that you can start seeing here, wherein it says, okay, there are some checks that have been completed. We need these checks to complete before we can let you send this for review or merge this code. What is that check? Well, the first check that is happening here is shift left next-gen static analysis, right? So imagine looking at the slides back again, a couple of things that we discussed as a flow, right? So first and important thing was I need to get immediate feedback. and I need to get this in my workflow. So my workflow here is GitHub, and in my pull request, I just use the browser as my IDE, right? A lot of developers do that these days with like VS Code and stuff. So this analysis in progress. Now let's see what is happening here. So when I click on details, it's saying, okay, I am going to check out this code. I'm going to look at your application. I'm going to scan it for vulnerabilities and issues, and I'm going to notify you, right? Now, one thing to note, like while I was speaking, so the next-gen static analysis here, it took like 59 seconds, right? And when I go back into the conversation window, what it says is, okay, see all of these issues, right? Wherein it says, okay, some checks were not successful, right? It failed. What failed? Static analysis check failed. It failed in 1 minute, right? So literally I can make a change, go get a cup of water, coffee, whatever you drink, come back to your desk, and you immediately got feedback for the change you made. Right? This was not the latest pull request. I had made some more changes before this. That's why there are more vulnerabilities. But here, if you can see, the first vulnerability that showed up is hard-coded secret credentials. Right? Now, let me click on this. So when I click on it, it immediately again gives me feedback. It takes me to details about the vulnerability, right? So it says, okay, hey, there was a secret found in mail.js at line 25. It is infrastructure service, it's related to Mailgun, it is an API key, the entropy value is significant, so we feel it's a pretty good match, it's pretty valid. It's of type secret, it's in this app. This is a hash. I mean, I could have given version numbers like x.y.c if you follow that standard. And then it gives you details of, okay, hey, why is this an issue? What are possible ways to make this different, right? Wherein you could, if it is being written into a log file or something for debugging, think of either redacting it, obfuscating it. If you're storing it somewhere, think of encrypting it. So multiple feedback immediately on what that issue is. And then for a developer, this one is important, right? So mail.js, line number 25. And when I see this, it's a link. So like when I click on it, again, it opens up a tab, takes me to that exact line in the original code saying, okay, this is the line that is different in your pull request, wherein this line is where that hard-coded key exists. Right? So it's 2 or 3 things to note. One is obviously the speed at which it happened at. Second is I didn't ever leave GitHub, right? I was within GitHub, within my workflow, within the pull request. And as soon as I made a change, within a minute, I got immediate feedback. And it is also giving me contextual feedback, right? Wherein it is taking me to giving me in-depth information. It is showing what the issue is. It is giving me a way to point me back into the exact line of code so I can fix it. And in the pull request, if you see, when some checks are not successful, and then you're seeing that there is a cross mark, and it says required status must pass before it's allowed to merge. Now, in normal organizations, you would have some assignee here for peer reviews, right? So when that peer reviewer comes in, they see this exact information, right? So what they would see is, okay, hey, I made a pull request. In a minute, there was all this feedback. Then it was not allowed to merge. I could go change it. I fix it. The check would again run. It would say these vulnerabilities are not existing anymore. And then the PR is then available for review. And so it's all in this single workflow. And if you think of back in the slide, it fits with that bug fix, unit test kind of workflow. Right? So that is how developers get immediate feedback. Now, if you go into the application, so this is not just a secret is straightforward, you would say, okay, hey, this is easy. This is something which is straightforward to find and fix. It's as simple as maybe just searching for a pattern, right? But it's not just secrets that we are looking for, right? We are looking for a host of other vulnerabilities as well, right? So when I go into, say, some of these vulnerabilities, right? So there are directory traversals, mail injection, NoSQL injection, and then not just for JavaScript. If I go into, okay, this was the application, so it was different. Okay, yeah, this was the application that we were looking at, right? So it's looking at all of these command injection vulnerabilities, request parameters. There's cross-site scripting attacks, directory traversal. There's a bunch of types of vulnerabilities that are detected as part of the scan. And this for JavaScript. I think I have a Java demo here. Yeah, so Java demo. Yeah, it again has all of these remote code execution, sensitive data leak, cross-site scripting, deserialization. So if I look at cross-site scripting here, like it gives you, like what I did was a one-line change in JavaScript. So it's easy to say that, hey, this is one-line change. I just point you to that line. But that's not where we stop, right? I mean, that's just where we start. Like if you see in this vulnerability, it's a complete flow of where that vulnerability started. So the source, all the transforms, right? And where it ends up as a sink. And look at the depth of that flow, right? It's a vulnerability that is spreading across like 10 different files, and we are able to track that entire flow from start to finish to help you as a developer find out where to fix this. Right? So this is also goes back to that initial discussion we had, where say if this ends in this file at the bottom, the owner of this module might say, hey, it's because this module is being used in the wrong way, right? Like if the input to this module, we expect it to be sanitized, you can't say, go fix the module to sanitize inputs. It's the onus is on the user to sanitize it. So then you can trace back the flow, you can go back into your code, and then you can figure out saying, okay, hey, maybe in this part, in this file, when I'm actually getting the social security number as an input, at that point, I should have sanitized it, or I should have validated the input before I start using it. Right? So it gives the developer full control over how to fix it. And then going back to that workflow, now you might decide, okay, hey, I don't want to just fail on any vulnerability that is found. I want to fail on specific type of vulnerabilities. And that is exactly how we suggest developers and organizations to use it. So if I come in here to the shift left YAML file, so you see here today it failed because our build rule that we have defined, a build rule in our terminology is the rule that is checked after the analysis is complete. And here we have said, okay, for any severity, fail the build, right? But this is very granular. It can be on specific types of vulnerabilities, category of vulnerabilities, severity. We can fail only on new vulnerabilities, not existing ones. So you don't need to keep failing your build because of debt, security debt. You only fail when you have introduced something new. So all of that is possible in the build rule. So this is what an application security team would own and define. So that's a quick overview of that flow. And that is exactly how we think feature bug workflows can be applied to vulnerabilities. Now, this is not just us showing us a demo, right? I mean, this is in real life. We have feedback from, like, say, Emirates as a customer, a major airline in the Middle East, a global airline rather, wherein they scan every pull request that is made by their engineers, and they are able to fix vulnerabilities far more efficiently, right? Where month over month, they are seeing a decline in mean time to remediation. But it is now even common for vulnerabilities to get fixed in that same sprint, right? Like some vulnerabilities introduced, and before it is even taken into staging or production, it is getting fixed. Right, so the vulnerability is never getting it into production or staging. So you don't need to even worry about having those secondary level checks in production, like firewalls and policies and second guessing what the application is doing. Because I mean, isn't it always better to fix the application versus putting a layer on top? So our experience with this in production, customers are obviously scanning more, right? Where a lot more scanning is happening. More organizations are scanning more frequently as part of every pull request, right? And what that effectively does is mean time to remediation, which is very key, right? For security teams, for the posture of the company. The quicker you remediate the vulnerability, the better. And so getting to like 5x remediation, improving in remediation it's very significant. And almost 70% of vulnerabilities are getting fixed in the same sprint. Right? I mean, you might ask, okay, hey, like if you can fail the build on everything, why don't everything get fixed? Well, that is where the policies come in, right? Wherein you might think, okay, hey, this is something which is an info vulnerability. It is not very critical. We are on a time crunch. We are looking at releasing this feature. And as a security decision, we are okay to let this go into the next sprint. But that's a very conscious decision that organizations can now take. Right? Where the organization is in control and they are deciding, saying, hey, we know of this vulnerability. We've known this as soon as it was introduced. But organization-wise, we are deciding that it is okay. Versus in the previous scenario, you didn't even know of the vulnerability till months of it being introduced. Right? So you are in control here versus just leaving it to a matter of chance. And yeah, a good amount of vulnerability are fixed right there, right? So like the one that I just showed you, where somebody hard-coded something, yeah, it's a matter of you got to know of it in a minute and you could fix it right there. Right? You don't even need to wait for the next sprint for that to be fixed. So let's look at just summarizing what we just saw so far from the demo and from the webinar. For an AppSec tool to work well for Dev-centric workflows, one, it needs to keep developers in mind. Right? Developers should never be forced to leave their environment. It needs to be immediate feedback. And developers love APIs, right? I mean, I don't want to go into yet another dashboard. If you can give me that initial information within GitHub, within my pull request, comment it into PR, I am happy. I can start with that. Don't expect me to like log into yet another system, start doing stuff there, like look for issues there, then come back to my code. No, like give me information, give me APIs, and I know how to deal with it, right? So that is very important. And it needs to be fast, right? If I don't get feedback within minutes of me making a change, I've already moved on, right? My priorities have changed. If I get feedback tomorrow, if I get feedback next week, yeah, it's already too late. And then things like concurrency. Like we've seen legacy static analysis tools where concurrency is not allowed. Maybe it's you need to pay extra for it. Two developers cannot scan at the same time, or if some major application is being scanned, you have to wait for your application to be scanned, which affects everything in the pipeline, right? You're not getting immediate feedback. You're like waiting. You might say, okay, let me just skip this scan. So those things happen. And the thing is accuracy and being able to teach developers, right? Accuracy, saying the false positive ratio, the true positive ratio. Look at tools, look at what they do on things like OWASP benchmark. That's an open tool where if an organization claims a certain percentage on it, you can believe it. And that primarily tests for two things. How many vulnerabilities can you find? That's true positive ratio. And of the ones you find, how many are actually not right? So the false positive ratio. Because the higher the the score, the more trustworthy the tool is. And then the less time you spend trying to make the tool work for you versus trusting the tool and focusing on what you do best. Build rules, right? That's one of the demo I showed you, wherein ability for applications security to define what vulnerabilities matter, right? So things like, okay, hey, an application is external facing, takes inputs from customers, touches the production database. I cannot risk having any SQL injection vulnerabilities in that application, right? So that is priority number 0. So you can set those rules. That helps developers also be trained to do better code, right? Like they are aware of what security principles are applicable for a project. And so they are trained in the process of writing better code. And last but not least, it needs to be comprehensive, right? Wherein when I make a line of change, and if I only look at that line in isolation, the implications are not very obvious, right? Wherein one example is, okay, hey, I'm taking an input from a file. I change that to take an input from a customer. Now, if you look at that line in isolation, as long as you are like validating the input, saying, okay, hey, there are no junk characters, or say the input should be less than 20 characters or something like that, it might be okay. But if you put it in context, that input might subsequently be touching the database. So if you don't check for SQL injection vectors in there, it could be an issue. Or maybe that input is used in creating crafting a URL. So if you're not looking for HTML characters, if you're not escaping it properly, it could lead to a cross-site scripting. Or if you're not looking, if that input is used later on to execute a command, well, maybe you shouldn't be taking an input from the user in the first place, because it could lead to remote code execution or directory traversal or vulnerabilities like that, right? So when you look at something in isolation, you don't see the full picture, right? So you need to be able to like perform full scans of an application, not just incremental scans. And then you need to be able to look for not just, so the example I showed you was secrets detection, which is easy, but then I also showed you the ability to look for OS top 10 vulnerabilities, sensitive data leaks, business logic flaws. You need to be able to look for that entire gamut of issues and not just focus on simple, straightforward linting kind of issues, right? So I hope this was useful. I hope you agree on these topics. Or, I mean, I'm obviously up for a discussion. That is the primary reason and goal for this webinar. So as I said, please send in questions. We've got 10 more minutes in the webinar. I'm happy to take any questions you might have. Just one thing to note, we do have a free account, and it is free, as in it's not a trial. It is free without any time limitations. There are limitations on features, obviously, because we have an enterprise offering which has like enterprise features. But the free account, anybody can sign up. All you need is an email ID. You could even go to the GitHub marketplace. There's a GitHub app, which makes it very easy to set up and start scanning. All you need is a GitHub account, right? You don't even need to create a separate login for Shift Left. It's a single click install from the marketplace. It's a free app. We set up everything for you in the behind the scenes to test out. You can run one of our demo apps. You can run one of your own code, scan it and try it out. The features that I mentioned in terms of build rules, integration into the pipeline, integrating it into GitHub, all of those are part of this free offering, right? There's no limits on those. So yeah, please feel free to check it out. Again, in any questions you have, I'm right here. So let me open up the questions panel and see what questions have come in. Give me a second when I figure out this one. Okay. Okay. Well, we've got like 15, 20 questions. Nice. Let me get to one of them. Okay. Okay, so yeah, so the question was, what if static analysis detected previously unfixed issues? So yeah, so that is a good point, and that is why when I mentioned build rules, I mentioned you can also decide or you can define the build rule for age of vulnerability. That you can clearly specify that only look at vulnerabilities that are newly introduced with this piece of code, with this pull request. So the developer is not penalized for vulnerabilities that are coming in from legacy code or from security debt. Right. So that is how we deal with that issue. I hope that answers the question. Integrating SAST into pull request might slow down the dev process, shouldn't be done in a later stage. So good question. What we have seen is, so yes, there are a couple of requirements for this to work effectively, right? One is speed of scanning. So as I showed you in the demo, what I did was a full analysis of the app, right? I wasn't just scanning that one line of code, which was evident from all the other vulnerabilities that it found. What we do is full scan. And then if you check out our website or our literature, we are like one of the fastest tool in the market. And when you're looking for tools for static analysis, that should be one of your criteria, looking at speed, right? As I said, if you're not able to scan and give me results in few minutes, it's not going to work. Completely in agreement. And then you mentioned about false positives. Again, very much true. When whatever tool you're looking at, you should be looking at what is their claim on false positive ratio, true positive ratio, and then how trustworthy is the feedback. So totally agree, it is relevant. Okay, let's go to the next questions. Oh, there was one thing saying, oh yeah, so GitHub has security scan inbuilt. Yes, so yeah, they do have security scans. GitHub also looks for things like hard-coded secrets. But the thing that I mentioned, the other issues, right? So where I showed you the hard-coded secret as a quick example because it's the easiest to do in a live demo by just uncommenting a couple of lines. But when I showed you the other examples, what we do is in-depth analysis of your code to look for all OS top 10 vulnerabilities, sensitive data leaks, business logic flaws, all of that, right? So that is where we differ, right? Where we are not just linting your code, we are not doing grep-like checks on your code for looking for patterns. We are doing in-depth data flow analysis of your application to look for deep-rooted vulnerabilities that might spread across modules, flow into system libraries and open source dependencies. That is what we do. And then that is how we are different. Let's see. Okay, so the one question was, how do developers go into, okay, do developers have to go to shift left IO to see the results? No, like when I did the demo, you saw within GitHub pull request itself, it was starting to print out messages saying, ID this vulnerability and a top level message on what that vulnerability is. That is just how I've done my API integration, but we are built API first. So every single piece of information that you see on our UI is available over API. So, I mean, you can go wild with it. You can print out complete information into GitHub. We have customers who've integrated it into GitHub comments. So as soon as you make a pull request, shift left starts putting comments directly into the diff in the PR, right? So instead of even in the PR comments, it can go into the PR diff itself, right? So when you go into the file, it will point out the line, it will give you this information, and you can make the fix right there. So yeah, you don't have to go into the shift left dashboard. It only depends on what you are comfortable with. We are flexible, and that's the reason we've given you these options. Totally up to the company who adopts the solution. Okay, how well does our engine support Python, Django, JavaScript, React? Yeah, so we support all of those. You can check it out in our the free account itself. So yeah, so Python, JavaScript, we support those languages. We support the frameworks you suggest. Yeah, so we do that. Do you have a workflow for trunk-based development or only feature-based, feature branch-based? This is the example that I gave you. We can be integrated into any flow in your CI system. We have customers who do it at the feature branch. They also do it at the master branch when releases are made. You can do it in the trunk-based development. It's totally up to you how you want to integrate or where you want to integrate. We allow integration in any place, right? Like any place you can invoke us, we can be integrated. That said, even developers can run it on their boxes itself, right? It doesn't have to be in the CI, but having it in the CI has its own advantages. It is enforced, it cannot be bypassed, and there is more checks and balances in place versus expecting a developer to do it and expecting them to use it. So yeah, so there's a question about does it support incremental scan? And I've heard some tools say they support incremental scan but require full scan. Exactly my point. So yeah, that's a very good question. Yes, there are legacy tools who say they do incremental scans, but after a few scans, they force you to do full scan anyways. And that is pretty much a trick to make you feel like the results are coming out faster. But overall, when you do an average, the results are actually very slow. When full scans might take hours or days to complete. Whereas in our case, we can do up to 250,000 lines of code in less than 30 seconds. Right? So that's kind of the speed at which we can analyze applications. So, and I mentioned in my last slide as to why we don't believe in incremental scans and why we always do full scans. And given the speed at which we do it, our full scans are actually even faster than competitors who are doing incremental scans. No questions from me. Really cool product. Thank you for the comment. That's good. What programming languages are supported? Again, you can sign up for the free account and you'll be able to see it. What will be when will be the recording available? You will be getting an email. Sorry that you missed the first 30 minutes, but yes, the recording will be available. And yeah, thank you for the comment that this out-of-the-box GitHub flow. Yeah, that is what is part of that self-serve free account you can sign up for. It is the top of the hour. We're actually a minute over. Thank you so much for attending and staying till the end. I'm gonna run the last poll. If you want to have a click before you leave, I would really appreciate it. Let me stop sharing. Okay, yeah. Thank you for taking the poll. And thank you again for the time that you spared to attend this webinar. I hope it was useful. Please do sign up at shiftleft.io/register, and you can try out the free account and all the features that we walked through. Thank you again for your time. Okay, I see there are still a few people online. There are some more questions that are coming in. So whoever is here, I'll answer them. So one was, I'm assuming a SAST is triggered by and runs as a GitHub action. Does this new container have cost implications for GitHub users? So yes, the free account does give you GitHub action minutes. And then as you saw, we just run for a few minutes, and not even few minutes, we run for just less than a minute. That is the additional time it takes more than what you build the code. So the implication is less. For free users, we mostly would even stay within the minutes that you have as free. But the cost implication is minimal compared to imagine having to provision hardware and run it and install software and having to scale it, etc. This is on-demand use just when you need it. Right? So that is how we work. Okay, so there's a question on how do you compare to tools like checkmarks? Well, one is the speed, and second is accuracy, and third is this entire workflow that we looked at, right? Wherein it was clear as to how easily integrated it is into the environment and AppSec workflow, and that is exactly how we differ. It is so easy to use, as I rightly said. I mean, I was a developer and I learned to hate static analysis tools because of how tough it is to use. But then you saw the feedback that we are getting from customers where they actually say developers like the tool. And that is very rare to hear from a developer about a SAST tool. Right? So that is how we primarily differ. Can I use shift left to scan compiled code? Yes, you can. For Java applications, you work on bytecode. So yes, you can. There are some applications, some programming languages, once compiled, makes it very obfuscated. So it is very difficult to do any analysis, meaningful analysis on it. So yeah, so unfortunately, we cannot work on those. Is it available on Bitbucket? Yes, you can look up our documentation. The marketplace integration today is with GitHub, but as I mentioned, anywhere you execute anywhere you can execute a command, it works, right? So we work on Jenkins, Bitbucket, GitLab, GitHub, on-prem solutions. We have customers who use us in in-house CI systems that they've just made using things like Kubernetes. We work with everything as long as you have like a Linux or a Windows environment to run us on. And that is also just the, we call it like a shim binary that just initiates a scan. Most of the extensive analysis happens on the cloud. So yeah, we integrate into any system out there. Let's see. How do you determine the severity level? We determine it based on CVSS score, right? That's a industry accepted method of looking at severity. It based on 7 to 8 factors of how is it easy to exploit? Is it in code? Is it in is it external facing? There's a bunch of factors that go into CVSS. I think it's called the Common Vulnerability Scoring System. And that's what we follow. So that's how we classify vulnerabilities. Let's see. Okay, when shift left is implemented against large code base, have developers complained about time taken to scan? Not really. As I mentioned, among our customers, there are large enterprises who have older legacy code, which come into the millions of lines of code, and even that we scan within 15 minutes. And the comparison to that is what they used to do was initiate a scan before they go home on weekends and come back, depending on the geography, come back on Monday, come back on Sunday, whenever they start the week, and pray and hope that the scan completed without crashing. Compared to that, when you can scan it within 15 minutes, yes, 15 minutes might be long, but compared to like it taking 2 days, 15 minutes is still a great improvement. And then most of those organizations are moving towards microservices, right? And then once they move that, it's all happening within seconds, right? So, so yeah, that happens very fast. Is there a relationship between industry type or company size to release frequency? Not really. I mean, even big companies are trying to release more frequently. There are born in the cloud companies who are just start with microservices from day one. So they just happen to release very frequently. But even big enterprises where we work with one company which has one code base, which is like 20, 30 years old, even that they're refactoring and breaking it into pieces so that they can release much faster, right? Like if you ask the question, would you want to release multiple times a day? I doubt anybody would say no, because I mean that's the only way they can keep up with the innovation and the demands that their customers have. So yeah, they definitely everybody wants to release more frequently. The last question, what's a healthy ratio of AppSec team to dev team when multiple releases are made in a month? Ideally, the question would be higher than what it is today, right? Like when, yeah, most organizations would love to have more AppSec folks, but unfortunately, reality doesn't work that way, where it is one, talent is tough to come by. It's tough to get good AppSec people. They are in high demand and not many of them who are good. And then when they're good, they're not cheap, right? So it is tough to find, it is expensive. And the only way to enable the AppSec teams in the company to do better is to enable them to have better tools and enable them to work better with developers, right? So that is a better solution than trying to just hire a lot of AppSec teams. Because, I mean, it is tough to do that. And even if you were to do that, if the quality of the AppSec people you're hiring is not good, it doesn't solve the problem, right? So yeah, I think I've answered all the questions. Thank you so much. I mean, this is a lot of questions that have come in. Okay, I see Lewis has reached out saying you're seeing an error when they registered. I would suggest if you could drop a note to support@shiftleft.io. I will copy this error message, but this error message might have come in from GitHub, so I don't know if I can track it down. So if you could drop a note to support@shiftleft.io, I'll definitely personally follow up and if needed, connect you with the right people in the organization. Right. Oh, okay. So Lewis said he's registered now and it's working. Perfect. Thank you so much. Please do try it out, Lewis. And as I said, that email doesn't change. Even if you find any more issues while trying it out, again, support@shiftleft.io. Within the dashboard on the right-hand bottom, you would have a link saying help. And when you click on that also, you can reach out. I'll personally be able to see those messages as also our support team. We're definitely ready to help in whatever way possible. It's 10 minutes over. Again, thank you so much for all the people who stayed on so long after the call. Okay, 85% of people have voted. That's amazing. Let me close this poll and share this. Cool. So yeah, so after the webinar, there's clearly a change in response. More people now believe in the number 1 point. That's what we were talking in the webinar. That's good to see. So thank you for this. 30% of people believe immediate feedback is more important than having better collaboration, right? Which is what we believe in Shift Left as well. So again, thank you so much. Appreciate all the questions, appreciate all the feedback, appreciate you guys signing up for the trial, the free account, and feel free to reach out at any point if you have any questions. Thank you.